Preparing for an Ansible interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is Ansible, and why is it used for configuration management and automation? Ansible is an agentless automation platform used to provision infrastructure, configure systems, deploy applications, and orchestrate workflows. It usually connects through SSH on Linux or WinRM on Windows, so managed hosts need no permanent agent. I describe desired state in YAML playbooks, while modules perform the changes. Idempotent modules avoid unnecessary updates, making repeated runs safe. Ansible is especially valuable because automation remains versionable, reviewable, and consistent across development, staging, and production. While answering, define Ansible's agentless architecture, declarative playbooks, YAML syntax, SSH or WinRM connectivity, idempotence, inventory management, and benefits such as repeatability, speed, and reduced configuration drift. Question 2. How does Ansible achieve idempotence, and why is it important? Idempotence means running the same automation repeatedly produces the same final state without unnecessary changes. For example, the package module checks whether a requested version is already installed before acting. This makes reruns safer and reduces downtime or configuration churn. I avoid shell and command tasks when a dedicated module exists. When commands are unavoidable, I use creates, removes, changed when, or failed when conditions. Idempotence is fundamental to reliable recovery and continuous delivery. Make sure to cover desired state, module checks before changing resources, safe repeated execution, changed versus OK results, non-idempotent commands, check mode, and techniques for making custom tasks reliably idempotent. Question 3. What are Ansible inventory files, and how do static and dynamic inventories differ? An inventory defines the hosts Ansible manages and organizes them into meaningful groups such as web servers or databases. A static inventory is maintained manually in INI or YAML, which works well for stable environments. A dynamic inventory plugin discovers resources from AWS, Azure, Kubernetes, or other platforms at runtime. I prefer dynamic inventory when infrastructure changes frequently, because it reduces stale host lists. Group and host variables then provide environment-specific configuration. In your answer, explain hosts, groups, child groups, host and group variables, INI versus YAML formats, dynamic inventory plugins, cloud discovery, and when each inventory approach is appropriate. Question 4. What is an Ansible playbook, and how are plays, tasks, and modules related? A playbook is a YAML document describing automation. Each play maps a set of hosts to variables, privilege settings, and an ordered list of tasks. Every task typically calls an Ansible module, such as package, template, or service, to perform one focused operation. A task can notify a handler, which runs only when something changes, such as restarting a service after configuration updates. This structure keeps automation readable and reusable. Be sure to mention that playbooks are YAML automation documents, plays target hosts, tasks describe ordered actions, modules perform operations, handlers respond to changes, and variables are conditionals control execution. Question 5. What are Ansible modules, and how would you choose between a module and a shell command? Modules are reusable units that abstract operations such as managing packages, files, users, services, cloud resources, and databases. I choose a module over shell whenever one provides the required capability because it usually offers idempotence, validation, structured output, and better portability. I use command or shell only for unsupported tools or narrowly specialized operations. In those cases, I add guards and explicit change detection so the task remains predictable. Focus on module purpose, idempotence, parameter validation, platform support, security, readability, command limitations, legitimate shell use cases, and checking module documentation before implementing workarounds. Question 6. How do Ansible variables work, and what is variable precedence? Variables let playbooks adapt across hosts and environments without duplicating tasks. They can come from role defaults, inventory, group or host variables, playbooks, registered results, facts, and extra variables. Ansible applies a defined precedence hierarchy, with extra vars generally overriding lower priority values. I keep defaults flexible, use group variables for environment configuration, and reserve extra vars for deliberate runtime overrides. Clear names and limited scope prevent difficult debugging. Explain variable sources including defaults, inventory, facts, play vars, role vars, extra vars, precedence ordering, scope, naming conventions, and avoiding unexpected overrides through clear variable ownership. Question 7. What are Ansible roles, and how do they improve playbook organization? A role packages related automation into a standard structure containing tasks, handlers, templates, files, defaults, variables, and metadata. For example, a web server role can install Nginx, render its configuration, enable the service, and expose configurable defaults. Roles improve reuse and make large repositories easier to navigate. I keep public inputs in defaults, hide implementation details in tasks, declare dependencies explicitly, and test roles independently before composing them. Mention standardized directory structure, tasks, handlers, templates, files, vars, defaults, metadata, dependencies, reuse, testing, role interfaces, and separating application concerns into independently maintainable components. Question 8. How do handlers work in Ansible, and when should you use them? Handlers are special tasks triggered by notifications from tasks that report a change. A common example is notifying a restart handler after rendering a service configuration. Ansible normally runs each notified handler once at the end of the relevant play, even if several tasks notify it. This prevents repeated restarts. I use handlers for change-dependent actions, not normal sequencing. If immediate execution is genuinely required, flush handlers can force them earlier. Cover notification, changed status, end of play execution, listen topics, multiple notifications, service restarts, flush handlers, and avoiding handlers for ordinary sequential tasks or unnecessary disruptive operations. Question 9. What is the difference between Ansible facts and registered variables? Facts are information Ansible gathers about a managed host, such as its operating system, interfaces, memory, and processor details. They are available through variables like Ansible Facts and support platform-aware decisions. A registered variable instead captures the result of one specific task, including stdout, stderr, return code, and changed status. I use facts for host characteristics and registered results for workflow decisions. Fact gathering can be disabled or cached when performance matters. Explain gathered host facts, setup behavior, hardware and operating system data, registered task results, stdout, return codes, change status, fact caching, and using both safely in conditionals. Question 10. How would you securely manage secrets in Ansible? I use Ansible Vault to encrypt sensitive variables or files before storing them in version control. Vault protects data at rest, while NoLog prevents secret values from appearing in task output. For larger organizations, I integrate Ansible with a secret manager such as HashiCorp Vault or a cloud secrets service, retrieving short-lived credentials when possible. I also restrict Vault access, rotate secrets, avoid command line leakage, and never commit plaintext passwords. In your answer, discuss Ansible Vault, encryption at rest, Vault identities, secret exposure in logs, NoLog, external secret managers, least privilege, rotation, and never committing plaintext credentials. Question 11. What is the difference between when, changed when, and failed when? The when keyword controls whether a task runs at all, usually based on facts or variables. Changed when controls whether Ansible reports that a task altered the system, which matters for handlers and summaries. Failed when defines whether a result should be treated as failure, overriding default return code behavior. For example, a diagnostic command may return a non-zero code during normal checks. I use these expressions carefully to preserve truthful automation results. Be sure to distinguish task execution conditions, change reporting, failure evaluation, Boolean expressions, command return codes, lists versus strings, and maintaining accurate output for dependable automation. Question 12. How would you deploy an application with Ansible while minimizing downtime? I would implement a rolling deployment using serial to process controlled host batches rather than updating every instance simultaneously. Before each batch, I would drain nodes from the load balancer, deploy the artifact, run migrations safely, restart only when needed, and execute health checks. Healthy nodes rejoin traffic. Failures stop the rollout through max fail percentage or explicit failures. I would retain the previous artifact and configuration so rollback remains fast. Cover serial execution, rolling deployments, load balancer draining, health checks, handlers, backups, migrations, rollback strategy, max fail percentage, and validating each batch before continuing. Question 13. What is Ansible Vault, and how would you use it in a team environment? Ansible Vault encrypts sensitive YAML files or values so they can safely reside in a repository. In a team, I separate development, staging, and production secrets, use Vault IDs for distinct encryption contexts, and retrieve passwords through protected C variables or a secret manager. Access is controlled through repository permissions and operational roles. I also document rotation procedures and ensure logs, diffs, and artifacts cannot expose decrypted content. Discuss encrypting files or individual variables, vault passwords or identities, C/CD integration, access control, rotation, repository practices, secret separation by environment, and avoiding shared unmanaged credentials. Question 14. How do you troubleshoot a failed Ansible playbook? I start with Ansible playbook syntax check, then verify inventory resolution and connectivity using Ansible inventory and ad hoc ping. I rerun with VVV when transport or module details are needed, use limit and start at task to shorten feedback, and add debug for relevant variables. I inspect privilege escalation, paths, facts, and registered results. Check mode can reveal intended changes, but I validate modules that do not fully support it. Mention verbose output, syntax checks, inventory validation, limit, start at task, debug, registered results, become permissions, connectivity, check mode, logs, and reproducing failures without weakening security. Question 15. How do Ansible tags work, and what are their advantages and risks? Tags label tasks, blocks, or role components so operators can run focused portions of a playbook with tags or exclude them with skip tags. They are useful for separating setup, deployment, validation, or maintenance operations. However, selectively running tasks can bypass prerequisites and create inconsistent state. I use tags as an operational convenience, not as a substitute for well-designed roles, and document dependencies clearly. Special tags like always require careful review. Explain tagging tasks, roles, and includes, selecting with tags or skip tags, always and never behavior, targeted execution, operational safeguards, and the risk of creating partial inconsistent system states. Question 16. What is Ansible check mode, and what are its limitations? Check mode is Ansible's dry run capability, invoked with check, that predicts changes without normally applying them. Combined with diff, it helps review configuration edits before deployment. Support depends on the module. Some modules cannot accurately determine future state, while command and shell require special handling. I use check mode for review and safety, but still test in an isolated environment because external APIs, scripts, and dependencies may behave differently. Cover dry run behavior, predicting changes, diff mode, module support, command and shell limitations, check mode conditionals, read-only validation, and never treating previews as a complete substitute for testing. Question 17. How do you improve Ansible performance for large infrastructures? For large inventories, I tune forks according to controller and network capacity, Enable SSH connection reuse, and use fact caching when host data changes slowly. I disable unnecessary fact gathering and avoid repeated package or command checks. Long-running work can use async with polling, while serial limits protect fragile services. I also reduce controller overhead by selecting efficient modules and organizing inventories intelligently. Performance tuning must not compromise rollout safety or observability. Focus on forks, fact caching, SSH multiplexing, pipelining, serial controls, async and poll, avoiding unnecessary tasks, efficient modules, inventory design, and balancing speed against resource pressure and safety. Question 18. How would you use Ansible for rolling updates across a clustered service? I would first understand the cluster's quorum and compatibility rules, then set a conservative serial value so enough healthy members remain available. Each batch is removed from traffic, updated, restarted if necessary, and validated through service-specific health checks before rejoining. I may use delegate2 for load balancer operations and pause between batches to observe metrics. Any quorum risk or failed validation should halt the rollout rather than continue automatically. Mention serial batches, service health, quorum, load balancing, pre-tasks, post-tasks, delegate2, pause, failure thresholds, version compatibility, and preventing simultaneous disruption of critical cluster members. Question 19. What is the difference between import tasks and include tasks? Import tasks is a static inclusion. Ansible parses the referenced tasks when loading the playbook, so tags, syntax, and structure are known early. Include tasks is dynamic and evaluated during execution, allowing conditions, loops, and runtime selected files. I use imports for predictable, fixed composition and includes when task selection depends on variables or host state. Understanding the distinction prevents surprising tag behavior and makes troubleshooting task paths easier. Explain static versus dynamic inclusion, parse time and runtime behavior, conditional evaluation, loops, tag propagation, variable visibility, debugging implications, and choosing based on whether task structure must be determined dynamically. Question 20. How would you test and maintain Ansible automation in a production team? I treat Ansible like application code. Store it in Git, require reviews, run Ansible lint and syntax checks in C, and test roles with Molecule against disposable containers or virtual machines. I verify both convergence and idempotence by running scenarios repeatedly, then perform integration tests in an environment resembling production. Dependencies and collections should be version pinned. Finally, I promote through environments gradually and document variables, assumptions, rollback, and ownership. Be sure to cover linting, syntax checks, molecule, idempotence tests, C pipelines, ephemeral environments, code review, version pinning, documentation, semantic changes, and safe promotion across environments. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.